This is Equipment AI, Nuclearn's equipment reliability platform for nuclear plants. In the next few minutes, you're going to see two things: how the platform is organized and what it tracks, and then a walkthrough of a single use case. The first thing Equipment AI shows you is the fleet view. Every unit at the site, risk scores and PM compliance rolled up automatically from sensor readings and work order history. In a real deployment, this is what's waiting for the system engineer when they open Equipment AI at the start of a shift. In the use case we're about to walk through, a unit like this one, flagged as elevated risk, is the starting point. Power operations calls with an adverse trend on the feed water pump. The system engineer needs to know what's happening and what to tell the operators. Let's follow that into the hierarchy. From the fleet view, you drill into the unit, then the system, then the specific equipment driving the score. 3 levels, each one narrows the question until you're looking at a single pump's sensor data, event timeline, and open work orders. This is the context a system engineer needs to make a call. You can compare locations within the same system with a single click. Here's the adjacent pump, completely different picture. That comparison is exactly how you tell the difference between a real process event and a single instrument issue. Now let me show you what this looks like when there's an actual alarm to work. This is the Equipment AI interface from main feed pump A. You can see the sensor chart grid on the left and the Atom Assist chat panel on the right. The combination of the data Equipment AI is gathering and being able to chat with Atom Assist in plain language to query that data is the true power of this setup. The engineer sets the date range to cover the window around the trouble report. That's the window Atom Assist will search. It queries the PyTime series data for that window specifically. If it needs to look further back to establish what normal looks like, it will do that automatically. You can see bearing oil pressure number 1 on the feed water pump, stable at around 12.3 for 2 days, then a sharp drop. That's the alarm. Now look at the other charts. Number 2 and number 3 show the identical drop at the same time. 3 transmitters dropping together, that rules out a single instrument fault immediately. And the lube oil supply pressure, stable, which tells you the issue is downstream of the main supply. The engineer sends the question. Atom Assist starts working. It's searching the sensor list, querying the time series data for the date range, pulling work orders, condition reports, procedures, and vendor manuals. The diagnosis comes back. Atom Assist has pulled the specific sensor readings and laid them out. Atom Assist is reading the system architecture and applying it to the data. Under documentary evidence, you see historical trouble reports from the prior year, all documenting nearly identical behavior. Atom Assist also surfaces a secondary finding: lube oil temperature increase as a viscosity effect. Less likely, but flagged. This is the differential diagnosis, not just one answer, but a ranked list of possibilities, each with its evidence, so the engineer can make an informed judgment. The key observations section synthesizes the logic. All 3 transmitters dropped together, single sensor failure ruled out. The drop was sudden, not a gradual degradation, and historical precedents exist for the TRs in the prior year with the same signature. Atom Assist will also suggest some actions. The engineer now has everything they need to brief the operators, write the cap entry, and decide what to do next. They didn't have to pull a single report manually. That's the power of Equipment AI and Atom Assist, a system that knows your equipment, your procedures, and your plant's operating history to amplify the expertise of your team.